Hello everyone, welcome to session 3 of the Schulich Ignite 2020 summer semester. This is being recorded after the session was done because due to technical issues, the recording was subpar. So we're recording it again here. So what we're going to be talking about today is we're going to start by doing a quick review of scope and global, which we talked about last time. Then we'll have an introduction to Booleans and if-else statements. And then finally, we'll finish off with relational and logical operators. So as we talked about last time, scope is a way of keeping track of which variables are accessible where. The easiest way that we could come up to analogize it was each function draw or setup is like a house. When you're in the house, you can only see things that are in the house unless you look outside specifically. If you want to do that, the way that you do that is using the keyword global. So I've opened up a processing window and put in a simple application to demonstrate global. This application is just intended to move a circle from the left side of the screen to the right side of the screen. Nothing fancy going on. However, this code won't actually work. In fact, if we run it, processing gives us an error. Not quite sure if you can see that, but you can see in general down at the bottom there's the red error here, and that is unbound local error. So that's telling us that in draw, it's looking for a local variable called x, but it can't find anything. And it doesn't know that it should look outside of draw for x. So the easy fix, tell it to look outside of draw for x by saying global x before using it. And when we run this, we get a ball that moves from left to right. In class we had this question, and we asked why won't this example work? The reason that this example won't work is very simple. It's the same as what I just told you. We can see that what we have in this example problem is we have a square that we are trying to move across the screen in both the x and y direction. But because we don't tell draw to go looking at the global scope for x and y, it looks locally instead, and it doesn't find anything, and so it gives us an error. So, with review out of the way, we're going to talk about Booleans. Booleans are another kind of variable, and they can only have the values true or false. We'll see later in this lecture that this is very useful for if statements, and even in future lectures we'll see that it's very useful for checking conditions in general. On the slides we have a couple of examples. So we have in high school, which for all of you should be true, and we have it's winter, which is currently false. It's summer outside. It's very important to remember to capitalize the first letter of true and false, or else processing won't recognize that that's what you're talking about. It will just think you're talking about a variable that you've called true or variable that you've called false. Up next, we have the comparison operators. So comparison operators are kind of like our math operators, which take in two numbers and return another number. Right? If we take 2 times 2, then we get 4. So that takes in the two numbers 2 and 2 and gives us back the number 4. The comparison operators take in two numbers and give us a Boolean. So on screen we can see all of the comparison operators we have access to. So we have less than or equal to, greater than or equal to, and not equal to. Those are all fairly intuitive in terms of what they mean. So less than checks to see if the first value is less than the second value, and if it is, it returns true. Otherwise, it returns false. One thing to make an important note of is that the equal to operation here uses two equal signs. In fact, that's because we've already used the one equal sign operator before. It's the assignment operator. So if we use a variable, say a equals 5, we're actually using a special operator called the assignment operator, which sets the value of a to be 5 in this particular case. This is different from the equal to comparison operator. The equal to comparison operator uses two equal signs. It's generally pronounced equals equals. So if we say a equals 5, that will not change the value of a. What it will do is check to see if the value of a is 5, and if it is, it will give us the Boolean true. If it isn't, it gives us the Boolean false. So to demonstrate the operators, I've put them all into a processing file, And what we will do is we will just have processing print out our comparisons against the number 4. It is, however, going to fail on this last line because here we're not using the equals operator, we're using the assignment operator, and that's because we just have the one equals sign here. So when we run this, we can see processing gets mad at us because we didn't give it a valid thing to print here. So for the moment, what we'll do is just get rid of this line by commenting it out and run the other ones to see what they do. We can see that we print first 4, which we expect, given that we set a to 4. Then we check to see if a is less than 4, which it isn't, it is 4. And we check to see if it's less than or equal to 4, which it is, so we print true. We check to see if a is greater than 4, which it isn't, because it is 4, so we print false. Then we check to see if it is greater than or equal to 4, which it is. Then we check to see if it is equal to 4, which it is. And we check to see if it is not equal to 4, which it isn't. So that should all make sense. It's all fairly straightforward. The only thing is that the syntax can be a little bit confusing. So the next thing we're talking about today is if statements. If statements are a very fundamental building block to most programs. The reason is they let us decide whether or not we want to run a particular piece of code depending on some condition. So up to now, every line of code that we've written is always executed, right? In setup, it's executed once. In draw, it's executed over and over again, just going back to the top every time. What if lets us do is keep some code from running, and it lets us decide whether or not we want code to run. So this is the basic setup for an if statement. We can see that what we have is a comment saying do some code before. That will always be executed, unless it's in another if statement. Then we have the line if condition. So this will run the code that follows only if condition is a Boolean and if it is true. So we can use our comparison operators, which give us back Boolean values. Or we can use a variable that we set to true or false. But we can't use something like if 0, which you can in other programming languages, so you may have seen it there. But in processing and in Python, we cannot do that. We need to use Booleans. And then the code that we want to run, only if the condition is true, we have to indent after the if condition line. Any code that is unindented after the if statement will be treated as going out of the if statement. And once you're out of the if statement, everything continues to run the same way that it did earlier. On the slides, we have an example of an if statement. This one checks to see if your house is cold, which in this case we regard as being less than 20 degrees. Then it sets furnace on to be true. In general, this would probably be some more complicated code that would turn on your furnace, but for the moment, just saying furnace on equals true will suffice. Note that the line furnace on is indented by 1 tab from the line if house temp is less than 20. Then after that, we have another if statement that says if house temp is greater than 25, furnace on equals false. So this is if your house is too hot, turn off the furnace. It's very important that you don't forget the colon at the end of the if condition line. That tells processing which is the code that you actually want it to only run if the condition is true. It tells it where to stop looking for the condition. Now on screen we have some example code that uses an if statement to determine what color to draw the background in. Okay, as you can see, I've copied the code into processing. What we're going to do first is step through it to see what we expect, and then we will run it to see if it matches. The first thing we do is set temperature to 36.00. This is a floating point value, or a float. That doesn't really matter right now, but in the future it sometimes is important whether values are floats or integers. By adding the 0.0, we make sure this is a float. Then we set the variable hot to the result of temperature greater than 25. This is the same as doing something like setting it to temperature times 2, except that instead of using a arithmetic operator, we're using a relational operator. So in this case, because temperature is 36, which is greater than 25, hot will be set to true. Then we set up our size and our default background, which is white. Then we say if hot, which with our current value is the case, hot is currently set to true. Then we're going to change what color we draw the background in. This is a light red or a pinkish color. And then what we do is we say fill 0, 0, 0, which sets our drawing color to black. And then we draw a rectangle for the ground, and we draw a rectangle for the body of the house, and a triangle for the roof of the house. So what we expect to see is the second image, with the house on a pink background. And this is exactly what we see. On the other hand, if we change temperature here to something like 18, which is less than 25, then hot will no longer be true. Hot will then be false. And so this will say if false, do this, which it won't do. So it will skip over this line, so our background will still be white. And that's exactly what we see. So on screen we can see an example of using an if statement to change when a circle draws. So we first draw a line down the center, and we say if mouse x is less than 250, so if we're in the left half of the screen, then we will say fill 25500, which is the color red. And then we draw a circle. And both of those are only done if mouse x is less than 250. So we can see that what that accomplishes is that the circle is only drawn when the mouse is on the left side of the screen. So once again, I've put this code into processing. In this case, I've put it into the draw loop. I've added some boilerplate around it just to make the program work correctly, stuff like background and size. One thing you'll notice that's slightly different on this one is that both sides will be white, so it is white on both sides of the line instead of being gray on one side. That's just because the code in the slides is slightly outdated for the GIF that we have, but we didn't want to overcomplicate the slides and didn't re-record the GIF, so this is what we have. But you can see the circle only draws when we are on the left side of my processing window. On the right side, it does not draw anything. So here's exercise 1 for this session. The exercise is to draw a circle at the top left-hand corner of the window. It should move horizontally to the right until it goes off the side of the window and disappears. And then you should make it reappear at the left after it moves off the screen. So on screen I have one way that you could attempt this particular exercise. This isn't the only way to do it, but this is a way that you could do it. So we'll step through it and then run it. So we start by setting up our global variable x. This will keep track of the position of our circle. And we have setup, which just sets our size to 800, 600. And then we have draw. In draw, we say global x, because we need to be working with the global variable x, so we need to tell draw to look for that in the global scope. Set our background to 0 and our fill color to white, which is 255. Then we draw a circle at x, 25, and 50. So I picked 25 here because it is half of our size, so this means the top of the ball should be touching the top of the screen. Then we say x plus equals 5, so we're moving to the right. And then we say if x is greater than 800, x equals 0. So this checks to see if the ball is off the right side of the screen, then we set it back to the left side of the screen. So we expect this to behave as the code on the slide does. And in fact, that's what we see. One thing we could use in conjunction with if statements is else. So else works a bit like the flowchart that you can see on the slide. So our condition here would be is driving, which would probably be a Boolean. If we are driving, then we want to send the call to voicemail when we receive a phone call. On the other hand, if we're not driving, then we want to let that through. Now we could do this with two if statements. So we could say if is driving equals true, then we send to voicemail. And then after that, we can say if is driving equals false, let it through. But the else statement lets us kind of bypass that by checking to see if it's true, do this, otherwise do this. Here we have an exercise demonstrating the behavior of if-else. So this is very similar to our earlier exercise drawing the disappearing ball. What we do is we first draw a line down the center of the screen. Then we say if mouse x is less than 250, i.e. if it is on the left side of the screen, then we fill with 255,00, which is the dark red. Then we draw a circle, mouse x, mouse y, 30. So this draws the circle at our current mouse position with size 30, exactly like we've been doing previously. On the other hand, if mouse x is not less than 250, so if mouse x less than 250 is false, then the code in the else block will run. And the code in the else block says fill 255, 150, 150, which is a light red or pink, and then draw a circle at 500 minus mouse x, mouse y, and 30. And 500 minus mouse x mirrors our x, the current position of our mouse, around the center of the screen horizontally. Once again, I've put the code into processing. As we already stepped through it on the slide, we're just going to run it and make sure it behaves the way we expect. On the left side of the screen, we draw a red circle that follows our mouse exactly. When we're on the right side of the screen, we draw a pink circle that follows our ball in the y direction, vertically, but is mirrored horizontally. That's exactly what we expected to happen. Here is the second exercise for today's session. What we would like you to do is take the circle from exercise 1, and we would like you to make it bounce and change directions when it hits the edge of the window. So, once again, we're going to go over this exercise. This is the sort of code I expect most of you will have come up with. It has some problems which we'll go over, but for the moment we'll talk about why you might have thought this, and then we'll talk about why it's slightly off from what you probably wanted. So we start, as before, by initializing ball sub x to 0. Then we use another global variable that we call ball sub vx. And v is used for velocity or speed. So generally, when we're talking about a speed of something, we will use the letter v. Then in setup, we set our size as usual. In draw, we specify our globals, we specify our background, and then we set our fill to be 255, which is, once again, white. Then we draw a circle at ball x, and y is 25, and our size is 50. Again, y is 25, so that the top of the ball is touching the top of the screen. We say ball x plus equals ball vx, so this is more or less the same so far, we're just using a variable instead of the number 5. But then we check to see if ball x is greater than 500, we say ball vx times equals minus 1. So this multiplies ball vx by minus 1, so it goes from 5 to minus 5. If ball x is not greater than 500, then we start going into our else block. And here's an example of some nested if. So when we have if statements inside of if statements, we call it nested. And here we have the nested if statement. If ball x less than 0, ball sub vx times equals minus 1 as well. And so what this does is it checks to see, is ball x greater than 500? If it is, then multiply ball vx by minus 1. So reverse our direction. Otherwise, if ball x is less than 0, so we're off the left side of the screen, we also want to reverse our speed because we want to bounce off the left side as well. So what we expect to see with this is a ball that bounces back and forth off of the walls. And this is kind of what we see, but you'll notice there's some differences between the way mine behaves and the way the one on the slides behaves. The main one is that the one on the slides bounces when the edge of the ball touches the screen, but mine bounces when the middle of the ball touches the edge of the screen. So this is a very common mistake to make, and one of the easiest fixes for it is to do something like this. We say ball radius is equal to 25. Now instead of saying y position is 25, we will say y position is ball radius. And the size that we're drawing our circle is 2 times ball radius. And thus far, we haven't changed anything. What we're going to do here, though, is we're going to check to see if ball x is less than 500 minus ball radius. So by doing this, we're checking to see if the center is at a point so that the right edge is at the right edge of the screen. Similarly, down here, we check to see if ball x is less than 0 plus ball radius. So what we would now expect to see is a ball that bounces when either of its edges touch the edge. That's not what we're going to see, though. What we're going to see is a ball that kind of just jitters in place. So what I'm actually going to do is lower my frame rate significantly so that you can see it. So you can see this ball jumping back and forth. So the problem is we're starting at 0. But our check here is we check to see if we are less than, in this case, 25. And if we are, then we reverse our direction. So on the first frame, the way that it goes is we draw our ball at 0, 25, 50. We say ball x plus equals ball vx, so ball x is now 5. We check to see if ball x is greater than 500 minus the radius. It isn't, so we go into our else block. Inside our else block, we check to see if ball x is less than ball radius. 5 is less than 25, so we turn around. This isn't what we want to do. So the easy way to fix this is just to also change the value of ball x. So we'll say ball vx times equals minus 1, and we'll set ball x to be equal to ball radius. So what we've done here conceptually is we've reversed the speed exactly as before, but we've also moved the ball to a valid position, and a position from where we know that it will behave correctly. We'll want to do something similar up here. So up here we will say ball x is equal to 500 minus ball radius. And this again checks if we're past the right side of the screen, it reverses our speed, and then sets our position to a position that we know is valid. And so when we run this one, and also change our frame rate back to normal, we see a ball that bounces off the edges. And this is what we wanted. So those are two tricks that are really useful for making circles especially behave the way you actually want them to. When you're checking the boundaries, you want to make sure that you're keeping in mind the radius of the ball. And when you are reversing your speed or colliding off of something, you want to move to a valid position. Generally, you want to move to the closest valid position. So in that last example, we used a nested if statement to accomplish checking against each wall. But we actually have a nicer way to do that. It's called elif. So this does exactly the same thing that we just did. So it checks to see if the first condition is true, and then if it isn't, it checks to see if the second condition is true. And if it runs different code depending on which of those is the case. We can also add an else block to elif, and the way that else blocks behave when there are elif statements is the else block will only run if none of the conditions were true. So you can see with the example on the slide, when we have price equals 33, we first check to see if price is greater than 40, we print it's too expensive, moving down the left side of this tree. But 33 is not greater than 40, so we go to our next statement. So we check to see elif price is greater than 30, which it is, we print it's a good deal. On this flowchart, that corresponds to going down the right side and then down the left side. Else, so if neither of those things were true, we print it's a great deal. And so that is going down the right side and then the right side. You can use more elif blocks. So if you had more conditions you wanted to check, so if you thought it would be a fantastic deal or a superb deal below 10, then you could check that as well. So what we will do to demonstrate is change this code to, instead of using the nested else then if, we'll just change it to use elif. We also need to change our indenting so that we're correctly indented. So now this will check to see if ball x is greater than 500 minus ball radius, i.e. if it's off the right side of the screen. Elif, so if that's not true, but this is, then we'll run this next bit. So we check to see if we are not off the right side of the screen, but we are off the left side of the screen, then we reverse our speed and move back so that we're in a valid position. And so when we run this, it behaves exactly the same. So we're now going to talk about logical expressions. So logical expressions are kind of like our relational operators from earlier, except our relational operators took in two numbers and gave us back a Boolean. Logical expressions take in two Booleans and give us back another Boolean. So some examples on screen, we have programming is fun and useful, and that is true, because programming is both fun and it is useful. On the other hand, the statement at 22 degrees Celsius, water is a liquid and water is a solid, is false, because at 22 degrees Celsius, water is not a solid. So we don't have both of them being true. The statement at 22 degrees Celsius, water is a liquid or water is a solid, on the other hand, is true, because one of those statements is true. One thing to keep in mind is that if we said programming is fun or programming is useful, in programming that would be true. So or effectively counts to see is at least one of them true. A lot of the time in regular English, when we use the word or, we mean what's called exclusive or, i.e. exactly one of these is true. But here we use not exclusive or, so that is just are either of these true or are both of these true. So in processing, I've set up all of the possible combinations of true and false for and so if we run this, we see that what the program prints is true, false, false, false. And that's what we expect, because only in the first statement, only in the first case, are both of them true. So true and true. On the other hand, true and false is false, because not both of them are true. Similarly for false and true, and then false and false, neither of them are true. So obviously it doesn't work. So I've taken the same code, but I've set it up using or instead. And if we run this, we see true, 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 false. And this is, again, this is what we expect. True or true says are at least one of these true. True or false, similarly, is at least one of these true. At least one of these is true, but exactly 0 of these are true. So false or false is false. We also have another logical operator that is not, and it's kind of like a minus sign. So in the same way that we can say minus x, we can say not true. Minus x will give us a negative value, not true will give us false, and not false will give us true. In exactly the same way that negative x is the same as positive x. We can also combine our logical operators in some interesting ways, like what you can see on screen here. So the classic green eggs and ham, if we do not like green eggs and we do not like ham, then we want to print I do not like green eggs and ham, I do not like them, Sam I am. No copyright infringement intended, Dr. Seuss. However, if either of those were true, then this wouldn't print, because we're using and. So we need not like green eggs to be true and not like ham to be true. What that means is we need like green eggs to be false, and we need like ham to be false. On screen we have an example that uses some relational operators, a logical operator, and the if-else construct. So what we do here is we say if mouse x is greater than 250 and mouse y is greater than 250, fill 02550, so fill with green. Else, fill with 00255, which is blue. And then, regardless, draw a circle at mouse x, mouse y, with size 30 in each direction. So once again, I've put the code in processing. In setup, we set our size. In draw, we set our background to a gray. And then we have our code from the slide. I'm not going to draw in those lines. You can if you would like to. When we run this, we see that in the top left quadrant, we're blue. In the lower left quadrant, we're blue. And in the upper right quadrant, we're blue. But in the bottom right quadrant, we draw in green. Our third example for today requests that you modify this code. So what we would like you to do is make it so that you draw as a different color in each quadrant. So on screen, I have some code for this example. Again, you could do it in a different way, but this is the way that I'm going to show you how to do it. So, stepping through it, setup does the same thing. It sets our size. Then in draw, we set our background as before. And as before, we still check to see if mouse x is greater than 250 and mouse y is greater than 250, meaning we're in the bottom right. We fill with green. But what we do next is instead of having else, we have elif, and here we check to see if mouse x is greater than 250 and mouse y is less than 250. This specifies that we're in the top right quadrant, because we're still on the right side of the screen, but we're now in the top. Then we check elif mouse x is less than 250 and mouse y is greater than 250. This checks to see if we're in the bottom left, right? Because mouse x less than 250 is left, and mouse y greater than 250 means we're in the bottom. And then we could use another elif block here, but we've already checked 3 of the quadrants and we're not in them. So we must be in the one that's left. And so we fill here with blue. Oh, and I don't think I mentioned it. The color for the top right is red. Color for the bottom left is yellow. And so we see bottom left, yellow, top left, blue, top right, red, bottom right, green. Exercise 4 for session 3 is to take our circle that we had from exercise 2, but we would like it to start in a random direction and bounce like old screensavers did. So once again, I'm going to go over my solution for this exercise. Your solutions may differ, but this is how I would do it personally. So I begin by defining my ball's radius as a global variable, that's 25, and then set ball x and y to be ball radius, which puts it in the top left corner, but in a position so that the left side of the ball is touching the left side of the screen, and the top side of the ball is touching the top side of the screen. Then I set up ball Vx and ball Vy to be 2 random numbers. And I do that by saying that they are a random number from 0 to 5, but as an integer, and then I add 3. The reason I added 3 was just I felt that it was going a bit slow for my taste. So now this is a random number, a random integer specifically, from 3 to 7, right? Because this is a random integer from 0 to 4, plus 3 gives us a random integer from 3 to 7. Then setup is the same as usual. Set it up 800 wide and 600 tall. Then in draw, I get all of my globals, and I set up my background in black. Then I draw my circle using ball x and ball y with the correct size, which I specify using ball radius. Then we say ball x plus equals ball vx and ball y plus equals ball vy. This is effectively the same as everything we've seen before. Whatever our speed is in the x direction, we're going to move that far. Whatever our speed is in the y direction, we're going to move that far. Then we check to see if ball x is greater than 800 minus the ball radius. So if we are on or going off of the right edge of the screen, then we say ball vx times equals -1. So we turn our speed around in the x direction. And then we set ball x equal to 800 minus ball radius. And we know that's a valid position, so we're safe to set it to that. Elif, so if we're not going off the right side of the screen, but we are going off the left side of the screen, so ball x is less than or equal to ball radius, then we still reverse our speed, so ball vx times equals -1, and we set ball x equal to ball radius, the closest valid position for where we went out. And then after we've done that, regardless of how these played out, we then also check for ball y. You can see there's no indenting on this, so this is not nested. These are just sequential. This one happens, and either this block runs, or this block runs, or neither of them run. And then we go do these, and then either this block runs, or this block runs, or neither of them run. So here we check to see if ball y is greater than or equal to 600 minus the ball radius. Once again, this is just checking to see if we're going over the bottom edge, but here we're checking to see if the bottom of the circle goes over the bottom edge of the screen. If it does, then we reverse our speed and set our y position to be the last valid y position. Otherwise, if ball y is less than or equal to radius, so we're going off the top edge of the screen, we again reverse our y speed and set our y position back to a valid number. And so when we run this, we can see a ball bouncing around. You can see it's moving in each direction. One thing that we can do to actually make this randomness feel a bit more random is remove this int on these. So because int rounds it down to the nearest integer, there's not a whole lot of different values, right? So that the way it was with int random 5 plus 3, we can either have 3, 4, 5, 6, or 7. Here we can have any decimal number as well. And so you can see we end up with a much steeper slope this time, although that could still have just happened by chance. And this also lets us go almost up to 8. Right? It won't ever be exactly 8, but we can get very, very close to 8. So this is now a random number between 3 and 8, where we can have 3, but we can't have 8. So at the end here, we have some more examples of things that you can work on. We have a Pong style game where you have a paddle and a ball. The ball bounces off the walls and also off the paddle. Then we have a physics style simulation where you have a ball that starts with some initial position and velocity, and then over time it falls down to the bottom and bounces, losing energy on each bounce. That is the end of our examples and of the content for session 3. If you have any questions, please feel free to ask. Otherwise, I will see you in the next one. Cheers!